So thank you for coming. Today we're going to talk about mainframes. And before we start, just a quick question. Did anybody see the movie Hidden Figures? It was released a couple of weeks ago. Yeah? Yeah, brilliant. Awesome movie. It's about space exploration in the 60s and black women's role in it, etc. It's a very awesome movie. And the reason I bring it is that it featured a mainframe. There was a mainframe that was actually used in the 60s to calculate trajectory, space exploration, etc. And they used this mainframe, the IBM 1790. So remember, this is in 60, 62, 63, right? And the reason I bring it up is because, well, here we are in 2017, and when I talk to people about mainframes, this is what they picture. This is what they have in mind. An old legacy platform that is only kept for historical reasons and because people cannot find the budget to replace it. And the idea, the whole idea of this talk is just to say that this statement is false for so many reasons, and we're going to go into that later on. This is what an actual mainframe, modern mainframe looks like. So without going into detailed specifications about failure prediction, the possibility to replace hardware live while the system is running, let's just look at the basic steps, right? We're talking about 141 processors, each 5 gigahertz. And we're talking about dedicated processors for each special tasks like XML processing, like Unix partition, etc. Cryptographic chips and hardware encryption. So it's the least we can say that it's a really badass machine, right? So it's like far away from what people imagine. It's not legacy if it's biannually updated. Same for the OS actually. It's like usually we find ZOS, IBM product, on this kind of machines. It's biannually product, there's a new release, there's patching going on, so it's not really legacy. This is a currently used platform. And obviously, if you have the money to spend on this kind of machine, you're not going to use it to host your mail server or your files that you don't care about. No, if you have this much money to spend on this machine, you're going to use it to host your most critical applications, the one that you do not want to go down. Actually, the uptime on these machines is not counted in weeks or months, it's counted in years, sometimes in decades. And so this is a slide that I took from my friends Phil and Chad talk that they gave a few months ago. I liked it so much, so I kind of stole it. It lists all the companies that use mainframe, and it goes something like this. The statement goes something like this. Somewhere in there, there's a company that you care about as an individual, as a member of society, be it a government, be it a bank, health insurance company, airlines, whatever. There is somewhere in there a company that you care about that hosts your data on a mainframe. If it's not on this slide, it's on this slide, right? And we could have kept going. This is just the list of a small list of the companies that rely on mainframes. There are different statistics. Some say it's 90% of Fortune 100. Some say it's 75% of Fortune 500. But the idea is this platform is not going anywhere. It's heavily used because it has uncomparable performance level, availability level, etc. So it is currently used, and will be used for many years to come. And we, the hacking community, do not spend nearly as much time as we do on Windows and Unix. We do not spend that much time on mainframe hacking, and that's just, well, sad, given how important this technology is. So this is basically the first myth that I wanted to debunk about this whole, legacy stuff. The second myth that, like, when I talk to people about mainframe, they're like, well, they're so behind so many layers of firewalls, like, they're well protected. We're not going to bother putting them in our audit plan. We're not going to scan them anyway, etc. That's just not true. Phil Young has a website that's called mainframeproject.tumblr.com. I encourage you to see it. He has a crawler that goes through the internet looking for mainframes exposed on the internet, right? So these are critical machines that host critical data, and yet we can find them on the internet. So this one I picked up on his website. You can pick up much more. This one I find interesting. I don't know if you can read it right here, but it says, Pentagon, so, US military apparently. There's also this one, car manufacturer. Actually, for the anecdote, I was trying to stock stuff, finance stuff. I was getting myself into stocks, and I found an insurance company that I bought some stock of. I found their mainframe on the internet, and I can tell you that I sold my stocks right away. So yeah, you can find some pretty critical mainframes on the internet. So a little bit about me. I'm Ayoub, work as a pen tester for Wavestone, like mainly Windows and Unix hacking. And I remember in 2014, we were doing an audit, like, infrastructure audit. The client gave us IP addresses, so we're doing our stuff, going through Windows and Unix stuff. And I remember that, we discovered some VLAN that was not listed, that were not given to us. And we hey, can we scan it a little bit? And he said, oh, no, that's mainframe, that's legacy. Do not do anything on it. Do not attempt anything on it. And we were like, well, that's mainframe. It's like finding gold. It's like finding a Windows 2000 or a Windows 3.1 on a network. You just want to exploit that shit. And we were so happy because we thought we were going to exploit it in so many ways. But when we went through the internet, and we tried to find resources on this stuff, it was dry as hell. We had no resources. We had no tools available. Well, one or two tools maybe. No techniques. There was nobody talking about this stuff. Well, there was only actually one person. So, I was so frustrated that I decided to get myself into this and just try to talk to people about this stuff and make them realize and make it easy for pen testers to hack this kind of stuff. So, this talk is going to be about demystifying mainframes a little bit, so, half check. We're going to talk about customer information control system, which is a critical product that we find on most mainframes, and we're going to hack the shit out of it. And then as a bonus, it's not really the purpose of this talk. I have a separate talk about this, but we're going to talk about some post-exploit stuff. Once you get a shell on a mainframe, and we will get a shell on a mainframe, what can we do? How to elevate privileges, how address space is handled, etc. So this is basically going to be the layout of the talk. So we're on an engagement. You have to pen test this app. This is what a mainframe app looks like. And the only info that we have, that I had when I started this pen test, when I had this in front of me, was that, oh, you can edit the green field. So you can input data in the green field. That's all I had going for me. So let's try to think rationally about this. Obviously, this is no web, right? So you can throw away all the XSS, SQL, etc. Not technically true, but we can discard it. If you launch a Wireshark, basically you'll see that the thick client that you're using is communicating with the protocol called TN3270, which is basically just a modified telnet, right? IBM modified telnet, called it TN3270. It has all the basic properties of telnet plus some added stuff. And to communicate with the mainframe, so we're going to use how is it called? An X3270 emulator on Linux. So it basically emulates this, this small hardware there. And like I said, we have no idea how it works. And I remember back in 2014, I was doing research on this stuff, and there was one talk by Dominic White, and he said, he showed the tool, very cool tool that would actually play with the fields in the same way as you disable, for instance, JavaScript on HTML. Well, you can do the same thing on this thick client. You can change the fields and make them unhidden, etc. And you can alter some fields that are protected, etc. But I wanted to go deeper. I wanted to really understand how this shit worked and what can you play with it, how can you play with it in the same way you would play with a web app, right? And this is where I discovered CICS, Customer Information Control System. Now, there are I think 100 books about CICS, from design implementation to definition. I'm just going to try to summarize all of it in one sentence, because I think that makes sense and will be much easier later on. So for me, this is a personal opinion, and it will shock most mainframe purists, but I don't care, they're jackasses. To me, CICS is a combination of a web CMS and Apache Tomcat, for instance, back in the 60s. So think of these two cool tools that were designed in the 60s, and they were so if we go to the mindset of the 60s, there was barely internet then. There was no TCP/IP. There was barely internet. Surely not in the same way as we mean internet right now. And so if you wanted to connect computers or to make an app available on different to different clients and to different mainframes, you had to do it the hard way. Go into assembly, code your sockets, handle concurrence access, handle memory, priority, etc. So you would have to do all the hard parts and assembly to handle all this stuff just to make your business app available. And so CICS came to act like a middleware. You would code your app in COBOL, Java, or C, or whatever, and you would host it on CICS in the same way you would host a Java app on Tomcat and make it available to everyone. So people would just connect to the CICS, using some standard stuff, and it will access different applications. And CICS will handle resource access, concurrence access, lock-in on files, etc. It will do that transparently. It's literally a small OS, basically. It's much more advanced than a Tomcat. And I say, like, I mentioned in Drupal here, like a web CMS example, because it's actually, CICS provides some functions that you can use in your code. So for instance, if we take a COBOL, I know everybody's familiar with COBOL, but it works the same way for Java and C. So you can see here that instead of reading a file using, custom COBOL code, well, we're just gonna use this exec CICS read file, and we're gonna read a file that's called Eurocli, and it will handle caching, it will handle concurrence access, it will lock the file, etc., integrity, etc. It will do all that stuff for us. So we only focus on the business aspect of the app. This is basically CICS. But the main advantage of CICS is that it can handle thousands and thousands of requests per second. Like, a lot. Let's just, this is a quick game. How many do you reckon, how many there are of Google searches per second in the world right now? Someone shout out a number? Oh, that's very generous of you. Well, actually, there are 68,000 requests per second in the world. Google search per the world. A little bit under 200,000 YouTube views per second in the world, but there are 1,200,000 requests going through CICS per second in the world. That would be all your ATM withdrawals, all your wire transfer, all your tax refunds, all your health payments, whatever, it's going through CICS. Bookings, airliners use it heavily. So everything that's critical, everything that we care about as a functioning society, half-functioning society, I would say, is running through CICS. So how does it work? What does it look like? Let's go through that. This is like when you download the 3270 emulator to connect to a mainframe on port 23, for instance, using Telnet. It's like you will go to the main interface on the mainframe. And this main welcoming screen is called VTAM, for Virtual Telecommunication Access Method. It's just a fancy word to say that it's a software driver that will handle TCP IP connection and SNA connection, like system network architecture connection, etc. It just handles communication and will let you access apps that you will not otherwise see during your normal port scan. And here you can see that we have access to two apps, right? Euro and TSO. Now, Euro is the business app, so we'll focus on that one. TSO is just a bin bash on a ZOS, the operating system on a mainframe. It's just, it lets you enter commands like netstat, like list user, etc. So we're not going to really talk a lot about it because it was covered in other talks by Phil Young and Chad. So I'm just going to focus on the business app. So we enter it, the green area you can always modify. So I enter it, Euro, and then we get a classic logon form where we have a user ID and password, classic authentication. If everything checks out, we go to the core business app where you can enter a customer number and you get details, right? Now, I want you to remember this ink one that's around here. We're going to see it later. So what happened under the hood was we were on VTAM, right, the main interface gateway on the mainframe. We entered Euro, and it took us to the CICS, what is called CICS region. It was just a fancy name to say it took us to the CICS instance that is running and hosting that app. That's it, basically. It's like, Apache, you have multiple forking processes that can be running on the same host. Well, same thing for CICS. You can have multiple processes, and each one hosting one specific app. So when it took us to the CICS instance or the CICS region, it fired the program, the default program that fires up in the beginning when you enter to this CICS instance. And in this case, it was the authentication program. Now, every program on CICS has a 4-digit ID that uniquely identifies it. It's called a transaction ID. And so in this case, it was CSN. And CSN basically is just a transaction ID, and CICS needs to resolve that transaction ID to a real program. In this case, it's DFH SNP, which is a default program that is shipped by IBM in CICS, and that lets, it handles authentication. And then, we get the name of the program in something called the program control table, and then CICS resolve this program into its real location in the program properties table, and then it loads up the program. Now, obviously, the program, since it's an authentication program, it will talk with a security product on mainframe. And most of the time on ZOS, it's RACF. So RACF does so much more than, it's like you can think of it as the PAM on Linux, but it does so much more. Like it handles every access on the mainframe. Like if you want to access a command, it's RACF. If you want to authenticate, it's RACF. It stores the hash, the password hash. It's DES, by the way. Although they're trying to change it right now and put AES. Anyway, so yeah, if everything checks out, we get to the second program, which has a second transaction ID dedicated, and it's the famous inc1, right? So this is really the business part of the program. And when we accessed it, so we entered the customer number, it loaded the file, and what happened was we executed, for instance, this macro that will, this CICS API that will load the file. And what happened was Eurocli is only a handle, a variable that points actually to a real location in the file control table, which is an internal structure in CICS as well. Since it has never been loaded, well, CICS gets it from disk, puts on the proper locks if needed, and then does the search in that file. Basically, this is how CICS works. It's nothing fancy, just normal middleware actions. So the idea is, now that we pretty much know how it works, let's try to and see what we can do with this stuff. Well, the first thing we want to do, the first reflex to have when you're on a pentesting, when you're pentesting CICS or an app, interactive app on a mainframe, it will most likely run on CICS, by the way. Every interactive app, the first thing that you want to do is try to jailbreak or get away from the app's context. Like if we're going to draw an analogy with the web pentesting, it's like finding the URL admin, trying to get away from the app and go to the admin panel on CICS. Now, on a web app, you would obviously search for the proper URL. On CICS, it's kind of different. You have to find the right keys to press in order to go back to what it's called the CICS terminal, and I'm going to show you. Now, sometimes it's PF3, sometimes it's PF12, sometimes it's reset and then PF3, sometimes it's reset and etc. But you have to find that right combination of tools I'm going to show you later on. By the way, everything that I speak about in this talk, like actually I've included in a tool that will automatically do all of this. It's called CICSpound. So you don't have to actually do pretty much everything here. It will do it automatically. The idea of this talk is just to be as educational as possible. So I want to take the time to really do this manually in front of you, not just show you a man of the tool and say, hey, this is how to use it. I want to really share so you can debug it and adapt it to your needs. So basically, just to give you a quick example. So for instance, here we enter Euro, right? We go to the authentication, and instead of authentication, we click on PF3. And then here we have a blank screen. Now, I promise you I was stuck on this blank screen for like a few hours, even I think a whole day. I did not know what I was. I did not, because there's 100 books. There's not a single page that says what the hell this is. And even if there is, good luck finding it. And I would just, click PF3, which is like exit command, and I would like close. I'm like, shit, I got disconnected, so I just close it and start again, not knowing what this was. This was a treasure map. This was, like, it happened when I realized it, when I pressed enter, just, like mistake, and it said, CICS transaction empty is not recognized. I'm like, holy shit, is he asking me which program to run? Turns out that's what it was. He was asking me to enter a transaction ID, an ID that will, corresponds to a program. So, and, when you have this new concept, like it's a whole new world opened up to me, and I was like, well, if I can tell him where to go, like I can maybe just enter the name inc1 and just bypass authentication. Like, are we obliged to go through the authentication program to access the business app? Like, that's a valid concern. And so I looked around, and when I set up like a talk I heard about earlier that's called by Dominic White, sorry. He actually developed a tool to brute force all the possible transactions ID, because that's the basic thing that you want to do, right? 4-digit, we can easily brute force it. And he developed a tool that's called mainframe brute. There's actually, like right now, there's a CICS enumeration script that does much more than that by Phil. Check it out. It's shipped by default with the new Nmap release. And I developed a tool that's called CICSshot that will actually list all the transaction IDs and will connect to each one of them and take a screenshot. That's basically it. But we can do much better than this. We can go much further. There are default programs that are shipped with every CICS installation by IBM. And we saw one earlier that's called CSN, which is the login program. But there are others that are much more interesting. And so this one, for instance, CMT, just the name, you know, like master terminal console, of course you want to check it. So there's CMT, and we're going to check it. What it does is, from that CICS terminal, you can enter CMT, and this is the master terminal console. It will handle every resource on CICS, right? This is really the admin panel. Like, if you can access this, it's like golden. You can change priorities of tasks, list the files that are used by the apps, shut down the whole system. You can basically remove files that were defined or programs that were defined. You can like list resources, etc. So we're just going to see a quick demo here. For instance, instead of brute forcing the transactions, we can just type inquire or I, and then we type transaction, and we get a list of all the transactions. So here we are on the CICS terminal. We type CMT and inquire transaction, and we access all the list of transactions, and we can zoom in on the ones that interest us. And so here, for instance, we see that, well, the program is called euro inquire, and like I said in the beginning, everything in green you can edit. So if you want to disable it, you just change ENA to this, basically, the IS, and that's it. And that's how we bring down an application that processes 300,000 euros per day, and your client gets pissed off. And if you want to get information about the system, like you can go much more. You can get information about the system, so you can type just inquire system, and you can see that we're on a CICS 3.2, ZOS 1.10. We have a default user, which is the equivalent of the anonymous user in FTP, right? So here we have CICS user, and FTP is anonymous. Because remember, we skipped authentication, so it's assigned as a default user ID. So everything that we're doing right now, we are doing it as an anonymous user. So that's the interesting part about it. And you can do some user scrapping. You can check for other user IDs that are currently connected to the CICS and get user IDs to later brute force and do some very interesting stuff on TSO. So if you want to list the files, because that's what we're after, right? We're after data. We're after financial records. We're after credit card data. So if you want to list the files that are used by the current business apps that are installed on CICS, you can just CMT inquire about file. And you can see here that files have a bunch of properties: closed, disabled, readable, and they're an identifier that identifies their location. So to read a file, it has to be opened, not closed. It has to be enabled, and it has to be readable. And to update it, obviously, you need to update or add attributes. So again, everything in green, you can edit. So if this file is closed, you can just open it and make it enabled and just read it. And files on ZOS are a bit different. Basically, they have a high-level qualifier. Like, some people are going to kill me for saying this, but it's like DNS, right? You have multiple qualifiers that are separated by point. That's it, by dot. That's it. And the files on CICS are different. They're special. They're called VSM KSDS file. Now, that's just a fancy name for saying it's a file that has 2 columns. One column is an index, so a number, and the other column is a value. So, for instance, you would have key 0001, and the data about customer number 0001. That's it. It's just like an indexed file, if you will, and you can get information, more information about the file actually by typing enter on the file, and you can get its real location, the key length, which is the index length, etc. So like I said, PF perform shutdown. You can just shut down the whole CICS. Funny story: when I typed this to take a screen, basically, I took my screen. I was happy. I was like, hey, I have my screen for the conference. But when I clicked on PF3 to go back, the nasty thing about ZOS is that when you click on PF3 to go back, it sends the command, then it exits. And so actually it sent the command and it performed the shutdown. And I was kind of screwed. So that's a second way to screw up your client if you want. So like I said, CMT can give you a lot of information about the system, about the CICS, but it will not let you read the content of the file, re-execute code, etc. That you cannot do with CMT. We need another tool that's called CSI. That's the third default program we're looking at today. And basically what it does, it lets you execute CICS APIs. So remember when I talked about CICS read file, these kind of APIs? What it just lets you execute them. And so if you have access to this one, again, we're going to do some pretty nasty stuff using this default program. So here we can see that we can read files. We're going to look at spool, open, close later, but you can see that we can pretty much like execute a lot of stuff on the program. So for instance, if you want to read a file, you just read file, you type its name that you got from CMT, RID 0 for the key index that you want to read. Obviously, we don't know if key index 0 exists, so we just add the keyword greater than or equal, and we get, well, not all the data, but some data, right? And this is the index, 400,001. So to get all the data, we need to store it in a variable, so we add the keyword into ampersand data, and it stores the value that is returned into a variable. And when you click on PF5, which is the variable panel, you can access the whole data. So to summarize, to read a file, we have to find the right key combination, go to CMT, inquire about the files, list them, get the properties like key index, etc., make the file readable, enabled, and open, and then go through CSI and then iterate over all the indexes. So that's pretty hard to do. So basically, that's what the tool comes in handy. It will perform all this stuff for you. So here we say that we're going to access Euro, that we're going to Eurocly. So we'll find the right combination of tools, and then it will list. It will change the attributes, and it will list all the content of the file automatically for you. So that's the first. But basically, like right here, we just read files, you know, like customer detailed files on the mainframes. Remember when I actually could have stopped here when I submitted to the conference because I was so happy. Because basically, remember when you're in a web pen test, you're like, oh yeah, I discovered, you know, this function that will let me read files, or this path traversal that reads files, and your customer goes, so? And you're like, well, I can read configuration files, I can get password data, password of the database, look, I have it. And he says, well, so? It's behind a firewall, you can't access it. Like, you know, fuck off. Well, you don't have this argument on a mainframe, because on the mainframe, every file that you read, at least in the ZOS partition, it's a customer file. Like, if you can read files, you know, the company is screwed. You have their most critical data. There's no other node. There's no other hoop to jump over. That's it. That's the end of the tunnel. If you get access to this machine, it's done. The company can just, like, you know, close the door because you accessed all the list of its file, of its customers, and all the most important data. So it is a pretty big deal to be able to read files. And in the end, that's what we want, right? We want to read files. We don't care about executing a shell or getting domain admin privileges if the customer data is not on Windows, right? We want customer data. That's it. We got them. We can, you know, continue our duties. But since we're in a hackathon, I figured, well, we kind of need to execute code. Like, people want to see some shell code, so let's dig deeper. Now, CSI has a nice feature that's called spool functions. Now, a spool on a mainframe is just the output of a program. That's it. It's just a temporary file, or just a file that has the output of a program. And CICS lets you create such files and push them to some components, or more like, actually, to some users, well, let's say components on ZOS. And so the idea is basically to create a spool file, this kind of file, write code into it, and then push it somewhere. And where we're going to push it? We're going to push it to somewhere, some place called the internal reader, or the job entry scheduler. Now, the internal reader, it used to be a physical slot on a mainframe where people would put punch cards that contain code, push it, and the punch cards get executed. Now, obviously, there's no such thing as a physical internal reader now, job entry scheduler. On a modern mainframe, they virtualized it. But it's still an internal component, and if you write a file, you push it to this internal reader, it will execute it. So the idea is, the theory behind this is just to use CICS to write a spool file that will contain code. First, we open a spool, we get the file descriptor that's called a token, classic stuff. We write line by line, and then we push it to the internal reader, and hopefully we get a shell. So it goes something like this. You use the spool, use the CSI menu, you go to spool open, user ID, this is critical, you put in intrdr, which is the handle for internal reader, not local, we want to execute code on this mainframe. We get a token descriptor, and then we prepare our code. Now, I know most of you are not familiar with GCL, which is the job control language, which is the scripting language that is used to run a program on a mainframe. But basically, I just want you to focus on this, like FTP 192, 168, 118. This is like, we just launch in a basic FTP connection to a server just to be sure that it's possible. And here we can see that we authenticate to the FTP and we just executed their command. That's it. It's as simple as that. And actually, it's not that difficult. It's just to learn, honestly. So we write our code, line by line using the variable panel and spool write. And we just, once we're done, spool close, we just close the file and we'll push it to the internal reader. And I was trying this for weeks just to understand how it worked and get it done. And finally, I noticed that, hey, I got the connection back. It worked. We can execute code. Now, obviously, this sucks for so many reasons. We're not going to write a complete, reverse shell just on the PF5 menu. It's horrible. And what if we want, some real reverse shell, how to do it, etc. So basically, this is where I decided to write a tool that will do it. So basically, we will go with this reverse shell. So it's a little bit more complicated than the previous one. So this is still GCL. This part is GCL. This part is GCL, right? So we just create a file. This is just some cards to say, hey, I want to create a file on disk. And I'm going to write this content into it. Now, this content is just, it's in Rex scripting language. It's kind of the equivalent of Python and ZOS, right? Just a scripting language. It's easy to perform some socket stuff, etc. So it's very, very handy. And so it just, opens a connection, reverse connection in Rex and execute whatever stuff we push to it. And in the end, we write this into a file that's called kicsuser.iv, and then we execute that file. That's it. And it goes something like this. So we open a connection with netcat, and then we use kickspawn and specify the payload -s reverse TSO. And like I said, it will find the proper way to bypass terminal and then write GCL, and then you can see that we have execution on the mainframe. And so here we have a TSO shell. Thanks. Now, I know most of you are not familiar with GCL, so I do not expect everyone to write this kind of code. So I just included some, classic payloads. Like, for instance, reverse TSO will open you a TSO shell. You can write commands. The syntax of TSO is quite basic. You have netstat command, you have ping command, you have list user. It's pretty documented. If you, reverse TSO, bind TSO. If you're not familiar with TSO, there are Unix commands that you can execute, because on every ZOS since 2000 and something, there's a Unix part, POSIX compliant Unix with regular ID find command. You can find your way around it. And so you can ask for a reverse Unix shell or a bind shell. If you want to exfiltrate file using this kind of technique, you can execute FTP commands using the kickspawn, so it's automated. If you don't want to leave your payload on disk, you can just write a stager, and the reverse shell will be executed in memory if you use these two payloads, reverse rex and direct rex. And if you're feel savvy enough in GCL, you can just write your own GCL. So these payloads are all included in the tool. So the idea is just to make it easy for everybody to hack mainframes. The second awesome stuff, I don't know if you noticed, but we did list user. We had this user, start2. And remember, we were running as anonymous user, but the code got executed using actually the user that was powering the kicks process. And you can see here that we have the attribute protected, which means this user is not supposed to have an interactive shell. Like if we go through the normal gateway and access, with telnet, etc., we will not be able to connect using this user because it has the attribute protected. And yet, we have an interactive shell. This is very important because when people set up this attribute, they didn't want other people to use this user's credentials because it just has so much power. And if you can see the running tasks on a mainframe, you can see that this same user is powering, Rakef, the security product. It's also powering VTAM, the interface that lets us interact with the mainframe. So this is a pretty big deal. This is a pretty interesting user. Even though the attributes said otherwise, it didn't have attributes. Well, actually, it didn't have classic attributes, but most of the time, these kind of users that are protected or that are used to power kicks have some extended attributes, specifically one that's called no-pass trusted attribute. And if you have this attribute, you cannot check it with a list user command yet, it's more advanced stuff, but if you have this attribute, you can bypass every security rule. Like even if there's a security rule that says, hey, your user cannot access this file, well, if you have the no pass trusted attribute, you can bypass that security rule. So it's not most of the time, but sometimes we found it on installations because basically CICS needs to access so many files. So instead of giving it, every time the proper security rule to access those files, they just say, well, let it be trusted and no, doesn't require passwords, so just let it bypass every security rule. And obviously using this shell, now you have those privileges, you inherited those privileges, so you can pretty much do whatever you want on the mainframe. So that's the interesting part. And now remember when we opened the spool file, that file that we wrote code in and we pushed to the internal reader? When we defined the file, we used the term node local. So we opened the file on the local system. What if we used node Washington, D.C., for instance, or a remote system? We could have executed code on another mainframe. Now, this is akin to Windows domains that are, that trust in each other. You can, if you have code execution on one domain, you have one user on one domain, you can, authenticate to another domain and do stuff. It's basically the same thing. Mainframes have the same, it's not called domain, but it's called network job entry. So if you can push code from one mainframe to another if there's a trust between them. There was a great talk on DEF CON last year about it by Phil and Chad, and they talked about NGE, network job entry, and they implemented the proper tools and Nmap, et cetera, to do it. But using this interface, you could just do it seamlessly. You don't have to care to get the right passwords, et cetera. You just specify the proper node, and boom goes the dynamite. Now, we have a lot of problems with this technique, although it works pretty well. First of all, what we see in the field is that sometimes, not all the time, but like on 9 mainframes that I saw, there was like spool functions that were turned off. So basically, we had on 4 of them, like on 9, about half, if you will, less than half. You had like on the CICS definition file, we have the spool set to no, which means we cannot write these spool files that we can push to the internal reader to execute code. That's a pickle, but no worry, there is another way to execute code, and that's through something that's called transient data queue. Now, that's just another fancy IBM word to say that we will define a file and we will make it available to people to write temporary data in it. It's like caching for apps on CICS. Like, you need to store data somewhere for a user, temporary cookie or whatever. You just write it in something that's called data queue, and you have a dedicated file on the mainframe to do so. And sometimes admins define a file, right, to store this temporary data, but they make it point toward the internal reader for, I don't know, some admin tasks or because they need to execute code or whatever. So it's always a good idea to look for this kind of stuff. And the way to do it is obviously through CMT, et cetera. But like the idea is that kickspawn will do it automatically. So if you launch kickspawn with the -i option, which will list information about the system, you can see that here we have the transaction that we have access to, information, and we hear GCL submission. We see that we can access the internal spool, but also TDQ. If you just need to specify -q IRDR, and it will find its way and execute code. So it's very automatic. You don't have to worry about it. Actually, on the 9 mainframes I told you about, like 4 displayed spool open that was open, and 1 had the TDQ. So like overall, more than half, you can execute code on it without authentication, because remember, hey, we skipped authentication. So that's a pretty huge number. So that's one down. The one that I really saw a lot, though, is CSI is not available. Like people, like on a mainframe when we connect to it, like we have access to CMT. That's almost always the case. But CSI, the one that executes CICS APIs, that one is most of the time forbidden. And like, oh, well, they've done their job. So we get this, a small error that was a little bit annoying. But the great thing is, to forbid CSI, for instance, there's a rule that goes something like this in RACF, R-defined, whatever. We don't need to care about this stuff. We just need to see that the protection is placed on the name of the transaction ID, on the name of the ID that lets you access the program, so CSI, and you can hear universal access none. So unless you have permission, you're not allowed to access it. Well, here we'll draw another tool from the toolbox of default programs shipped by IBM. This one is called CEDA. Now, this one lets you alter resources that are defined in CICS. So remember the file name variable, the name of the program, the name of transactions, you can change all of that. And this one is, like if you have access to this one, that's it, they're screwed. Like you can do pretty much whatever you want with the system. And the weird thing is, CSI is most of the time, you know, like not available, but CEDA always is. And it's insane. There's CEDA, which will let you alter resources in real time, and there's CDB, which will let you alter resources, but you have to reboot CICS. So that's a bit more troublesome. But CEDA works great. And the idea is, since the protection was put on the transaction ID, well, and the transaction ID points to a program, what if we can change a transaction to point another transaction that we have access to and make it point toward that CSI program? You know, and we have a list of transactions that we can access, like the logon authentication, for instance. That's a transaction everybody has to access, right? What if we make it point towards the CSI program? Obviously, that will screw up the mainframe, but you get the idea. So instead of using the login transaction, we're going to use some other transactions that people don't use, other IDs, like the print-in transaction, CSPK, and the page-in one, CSPS. So you will not have to do this manually. Again, like Xbound will do it automatically. You just use the -- bypass, and we'll do all this stuff too automatically. So for instance, here we want to reverse Unix, and you can see that we cannot access CSI. We tried the -- bypass switch. And you can see that here it will copy CSPS, and it will make it point to CMT. CSPK points to CSI now, and you can see that it's correctly submitted the code. And you can see here that we actually have code execution again. So I have 18 minutes left. Brilliant. We're going to talk about code privilege escalation. So we have code execution on the mainframe, right? Either through CICS or through any other means, FTP code execution, sniffing credentials, getting access to TOS or whatever. We have access to mainframe. Either our user has lots of privileges, and then we can just download the database of passwords, crack it. Most of the time it's dead, so you can get away with it. But what if we don't have privilege access? How does privilege escalation on a mainframe work? Is it even possible? What are the tools? This is basically what we're going to talk about a little bit. So basically on RACF, on the security product on ZOS, you have three main privileges that you should always have in mind. So there's special, which is the equivalent of root, right? If you have access to this one, you can do pretty much whatever you want on the system. You're king in the world, or king of the world. You have the operations attribute. And this one lets you bypass any security rule there is. So if you have this attribute, and there's a rule that says, hey, you don't have access to this file, you can just bypass it and ignore it totally. And then there's the auditor privilege attribute that will let you access some class, login classes, etc. It's not that much useful to us. Now, when you connect to a mainframe, basically every job on a mainframe, every program, every user task has its own address space. And in the address space, basically, you have two main parts. You have the common part, which is called the Common Storage Area, CSA. This one is shared between all users. It contains some critical functions, some syscall table, some important common definitions that has to be accessible to everyone. And then you have the private part. Private part, only your address space, only you in the address space can access it in the same way, basically, as every other modern operating system. And now in that small private address space, small private address region, sorry, you have a special structure that summarizes your privileges, that contains your privileges. And this structure is called the ACE, for Accessor Environment Element. And on offset 26 hex, you have one bit that says, hey, this user has special or not. And then you have other attributes like operations auditor, etc. So what if, we can change this stuff? What if we can change this, this part of memory that, summarizes our attributes? Obviously, this part of memory is not writable by everybody. You have to be in kernel mode to write it. So kernel mode, mainframe, how does it work? Let's dive into it a little bit. So basically, on Unix, if you want to load the kernel into memory, if you want to load the kernel, you basically just use the insmod command or modprob or whatever, and you just compile a program and load it into kernel. The privilege is set on the command to load it, not on the program that is loaded. We agree on that. On the mainframe, it's different. On ZOS, it's different. You have some special folders, and everything you put in it will run with kernel privileges. Which means the protection must be put on the folders, not on the command loading them, which makes it so much harder to tighten, to secure, because you have so many directories, sometimes 30, 40 directories that you have to protect. And so this is what's called APF libraries, so authorized program facilities. So these directories or libraries, everything you put in them, they're critical to the system. Everybody can list them. If you put a program in it, if you have write access to them, the program, when it will launch, it can request kernel privileges, and it will get it. And so, obviously, these libraries are well protected, not so much. I remember when we were doing an audit, we way back then, I basically didn't have these tools that I'm showing you right now. And we saw some APF libraries that were alter to everybody, and we were like, hey, this is bad. I've read about this stuff. It's bad. You should not be doing it. And I remember my client said, oh yeah, you're right. Yeah, can you show me what people can do with it? And I'm like, no, I don't know. Writing assembly and ZOS, no, I don't know how to do that. Fuck, there's no other tool to do it. And so the idea is just I went straight home and tried to, really learn how to code this stuff and how to do it, because, ZOS assembly is different from x86, so it's a whole other language, basically, and a whole other architecture. And so the idea is just to make it easy, super easy for people, just, in pen testing, oh yeah, you have alter access to an APF library, you could just launch code and, hey, I'm roots of your system, just like you would on when launching Mimikatz or whatever. The theory is fine, but let's do some practice. Let's transform this one slide knowledge lost somewhere into a real tool that we can actually use and demonstrate and an engagement. And so the idea is to write in assembly a code that will list all the APF libraries, that will check privileges of each one, and that will basically compile a program into those with proper linking attributes that will make it go into kernel mode, and then launch it. The program will just locate that bit of memory that holds your attributes, and then flip it. And then there you go, you're special. So basically, it looks a little bit like this. This is the program that we will compile. So this part is just, saving registers, etc. Just classic saving routine in assembly. And here, this is the modset macro, and it will let you go to request kernel privileges. So we go into superior mode. We change the keyring 0 to king 0. And then we find the address space pointer in the common place area, so ASCB. We go into the extended part of the address space, and there we find a pointer to ACE, which is the place that holds our data. And basically, we just flip the bit number 26, 25 and 26, and we flip another bit to have alter access to everything. We resave everything, and then we exit, and then that's it. And the idea is, basically what this program does, this will launch a program, so it will make the program special in its own address space, but it will not make your user special because it has a different address space. So what we did here, we made the program, we elevated the program's privileges, so now we need to elevate our user's privileges, hence the small alter user ID special operations at the end of the program. And it basically looks like this. So we're on interactive shell on a mainframe, and list user, we can see attributes 0, we don't have anything. We execute elv APF list, we can see a list of all APF libraries, and you can see that none of them are protected. And you can see that, it's a pretty big list. Obviously, just, test system. So you can execute user, we choose one, link lib, and it will compile the program, launch it, everything went well, and you can see that here we are special, and we have the operations, and that's how you do an escalation, privilege escalation on a mainframe. And thank you. So, a lot of thanks to a lot of people that I work with, mainframe, big Indian smalls, Mark Wilson, a lot of people, IBM, thank you very much. And yeah, so if you have any questions, I think there's still 10 minutes. If you have any questions, please go ahead.
Any questions? No? Well, more a case of maybe the questions will come off stage.
Thank you.
Thank you very much. Thank you.
Thank you very much.
Thank you for your presentation today.